Hey everybody, so we're going to be talking about discrete domain and range here today. Now we've talked about the words domain and range and how they talk about your x values and your y values, but we've not talked about this word right here, discrete. Think about discrete as individual points. They are they're discrete like a covert operator. Somebody who's discrete is kind of like a spy. They keep to themselves. Pretty much when you're looking at them on a graph or anywhere else, they're just points. And you'll notice that's why that's why I've written discrete out like this, is that it's each own specific letter. It needs its space, y'all. All right. Now, before we go into this and we talk about domain and range, we have to remember our dear friend, Dr. Idiot. So, if you'll remember, Dr. Idiot helps us to remember all of the different ways that we can say domain and range and your x values and your y values. So, we're going to go ahead and set them up. DRIDIO. And don't worry, don't hesitate. You remember the T is a T chart. So, fill in your T chart. We've got domain, range, your independent variable or values, your dependent variables or values, your input, your output. And as with your T chart that we usually do, this is our X value and these are our Y values. And I like to put values in there so we remember that's what it's referencing. Yay! And now we remember Dr. Idiot and we won't feel like he does anyways. All right, so let's talk about domain first. So domain, oh my gosh, we just talked about it. The domain is a set of all possible x values of a function. Now remember, the other names for domain, it's independent variables, and your input. So pretty much, and you guys want to remember that you are nice, polite people. So when we are listing out domain, we are doing it from least to greatest. And we're going to do it inside of these curly brackets. If you ever have repeats, remember, mathematicians are lazy. We're not going to write it more than one time. So let's look at it if we just have ordered pairs. What I like to do is if I've got a lot of ordered pairs like these, I like to underline my x values here. And then I look, okay, I've got a 0, 1, 2, 3, no repetition. Awesome. And it's in least to greatest order for me? Heck yeah. So I'm going to do my curly bracket. 0, 1, 2, 3. And guess what? This right here, that's your domain. You're done. All right, so let's keep going. Now, sometimes you're going to get problems that are a little bit harder than that. I know. But you can do this. So this one's asking you, what is the domain of the function f of x equals 2x? And oops, it's a little funny there. So we're going to add that over here. And get rid of this plus 3. There we go. Given that the range is -1, 3, 7. So pretty much what they've done for us is they've given us our y values and they want us to find our x. You can do this. Here's what we're going to do. All right, so it says f of x, and I would like to just start off with this one right here. So f of x, which is our output, is -1 in this case, and we're going to set it equal to 2x plus 3 and solve for our x. So I subtract 3, you have negative 4 equals 2x. Divide that by 2, and x is going to equal negative 2. So far our domain, we've got a negative 2 here. And now we're going to keep going with the rest of them. All right, so now we've got 3, so I'm going to set it 3 equals 2x plus 3, subtract 3, these 0 out, 0 equals 2x. Well, hey, 0 divided by anything, that's just going to give me 0. That one was easy. And then this next one, we've got one more. Again, set each of your range to the equation so that you can solve for the domain values or your input. Right, and luckily, when we ended up going in least to greatest order for our range, we got least to greatest order for our domain here. So it's going to be easy for us to write our answer as negative 2, 0, 2, curly bracket. See, that wasn't so bad. All right, so now sometimes you're either going to get it as a table or as a mapping. Now, you guys have seen the mappings when you were in 8th grade. All right. When you're looking at the domain, again, same thing, least to greatest and only your x value. So in this case, it's already in least to greatest order. And there are no repeats. So you can easily just do your curly bracket, negative 1, 0, 1, 2. You're done, son. That's how easy that one was. And typically, that's also the case when you have a mapping. Because check out your x values right here. They're in order from least to greatest. So you can write your domain as least to greatest with your curly bracket. And hopefully yours turned out much better than mine. You get negative 2, negative 1, 0, 1. That's how easy that is, guys. So, it's this next one that most people are like, oh my gosh, guys, I hate graphing. No. Well, guys, don't worry about it. You're only having to look at the domain. So when you're only looking at the domain, watch this. You're only looking at your x values, right? We'll start from left to right because that's how it goes from least to greatest. And here is your first x value, which is negative 1, 0, 1, 2, 3, and that one is at 5. Right? Sorry, Miss Somji couldn't count for a second. There we go. And guess what? That's your domain. You're done. So let's try it with this one right here. And these are spread out a little bit more. And that's okay. You're going to do the same thing and do it least to greatest. So start left to right. So our first one right here is going to be at negative 5. Now, I've forgotten something very important here. I need my curly bracket. And because my blue is a little bit thinner, I'm going to keep writing in the blue. Negative 5, then this one's at negative 2. And notice how I'm moving from left to right here. So it helps me keep it in least to greatest order. Then I've got it at 1. And lastly, right here, I have it at 4. And here is your domain. It's really that easy when you're working with discrete, guys. You're just counting and putting things in numerical order. And the same thing's going to happen right here when we go into our discrete range. So before we get started, of course, we're going to fill out our information that we know. And you guys all know this. The set of all possible y values of a function and the other names for range are your dependent variable and your output, right? So same thing here. When I see just ordered pairs, I underline right here my y values. Now remember, if any of these y values were to repeat, it would be fine. We wouldn't rewrite them twice, but it would not affect whether this relation is a function or not. That only happens when your x's repeat. And just like in real life, they shouldn't. So let's go ahead and write our range in. 4, 5, 6, 7, because it's already in least to greatest order. Oh yeah. Now, this next one, you're probably like, oh my gosh, I have to do so much algebra. But you don't this time, guys. Are you ready? When it's asking for the range, and they've given you the domain and the function, all you are going to be doing is evaluating, which you guys know how to do. When you're trying to find f of -2, and you're using this function right here, 2x minus 3, all you're replacing is that x with that number in there. And you can do that. 2 times -2, that's -4, minus 3 is going to get us a -7. And notice I'm going in least to greatest order as well again. So that way, hopefully, I can get my range to come out in least to greatest order as well. All right, so this time I've got f of 0. Minus 3, okay. So 2 times 0 is, well, 0. And 0 minus 3 is going to be -3. All right, so far we're in least to greatest order. We have hope, guys. All right, then we've got f of 2 right here. We've got 2 times 2 minus our 3. It's 4 minus 3, and that'll get you a 1. And oh my gosh, guys, we lucked out again. Least to greatest. But typically, if you do your domain that's least to greatest, and you're plugging it in that order, your range is going to come out in least to greatest order as well. And this is your answer. And now, here are the easy parts right here. Okay, so we are going to go right here at our table. And remember, we're going to be writing our range from least to greatest order. But you'll notice this is swapped in what we had for the domain. So what we're going to do is we're still going to write it in least to greatest order. We've got 5, 2, -1, -4. Well, we've got -4, -1, 2, 5. And luckily for us, it was just in reverse order this time. And this one right here, this one's a little bit different. It looks similar, but when it's in a mapping, most of the time, remember, most, it's already going to be in least to greatest order. Now, unfortunately, our test makers, they're not always the most polite people, so always check your mapping and see if it actually is in least to greatest order. And of course, because we are your teachers and we love you, we are polite people, we already put it in least to greatest order, so you can just copy it down. And that's your range. Now here it is with the graph. Remember, for our x values, we went to that x value and drew a line where everything could hit that, right? So right here, we drew an entire line to get all of when x was equal to 1. We're going to do something similar here when we're working with range. But remember, when you're working with range, you're working with your y values. So, and you want to go from least to greatest. Your lowest y value is at the bottom, and you go to the top, bottom to top. So let's go here. Our lowest number is right here. And that's when your y value is at -6. And then we're going to work our way up. And it's right here, which is at y is equal to -3. Then we keep going up, and we're at y equals 0. Keep going. You're at 3, and then you're at 6. So we're going to go ahead and do this next one as well. Again, you're going to start from the bottom, which is where your lowest y values are. And in this case, it is also, I believe, 1, 2, 3, 4, 5, 6, -6 right here. -2, because we walked on up. Then we keep going, and then we hit right here at +2. And we go all the way up, and we hit at +6. And that's how you would end up writing your range. Now, this is discrete domain and range. Remember, you want to think of them as covert operators. Notice they are there each little point when it's on a graph right here. See, they're each little point. They're discrete. They keep to themselves, guys. Just like you don't want your secrets to get out, you keep them discreet. You're a discreet person then. So, good luck. You've got this. And guys, you can count. You can put things in least to greatest order. So please continue to be polite mathematicians.